Linear probabilistic modeling. Through an engineer's career, we will use different models to approach different problems we will face, and one of them is the linear probabilistic modeling. So what is it? Probability models show us the distribution of an outcome variable condition to a group of explanatory variables across individuals. This can help us determine future outcomes without executing any test or sampling, just based on the data we have previously collected. This can help us denote the predicted variables and probabilities for a single outcome at the individual level as Pi equals PR Yi equals Y dependent of X. And for applications, we can see that engineers will be able to reduce testing time and estimate any possible outcome based on extreme adjustments to their experiments. For example, we can be able to tell what probability of eye damage a high refresh rate display costs to a user by just testing lower but easier to transport and set up displays. Then we can have here the formula for the probabilistic modeling. So y is equal to the success rate, which will be equal to the probability when h is equal to 0 or beta naught, plus the probability when h is greater than 0, plus the random error, which will give us any sort of coverage for unconsidered variables for our experiment. And we can see here an example application for an AI adapting to the conditions of a car's hardware over time by running a track several times and counting the amount of successful perfect runs it does each time. We can see how the AI adapts and makes the number of successful runs rise as time goes and allows to predict the success rate after some sampling is done. This way we can save time and know where it's going to be in a certain amount of time. In case we're selling this to a customer, we can easily tell around how many days it should be calibrated for the best performance on a certain trip the customer does on a daily basis. And finally, we have here our third graph, which is another way of using the probability model, which is considering binary outcomes. We can make this graph by using Excel tools, and for example, we can use it to get estimate of a solar panel efficiency over time, making it as if 1 we achieve the wattage goal and 0 if we didn't. Combining this with the confidence interval, we can achieve an easy to show and explain graph that can also predict the probability of our preferred outcome. And that's pretty much it for this video.